so there are cells on the collecting duct and the distal convoluted tubule that are specialized to, they're sensitive to aldosterone. So these are called principal cells. Principal cells. And again, they're on the collecting duct and distal convoluted tubule, and they are sensitive to aldosterone. Okay, so if we have our tubule, so we're going to put the lumen over here, and I'm going to zoom in a big cuboidal cell on the wall of the tubule there. So the lumen is here, the collecting duct or the distal convoluted tubule is here, and then over here we have our blood. Okay. All right, so basically what's happening is, we have our angiotensin II, it's doing its thing, making us thirsty, increasing cardiac output, doing all of that, and it's also stimulating aldosterone. So aldosterone comes in the blood. So aldosterone goes in the blood. So we have our little pieces of hormone here floating in. And when it gets to these cells, where is the receptor for aldosterone? Well, remember, this is a steroid hormone. So the receptor is inside the cell. So it comes in and binds to the receptor inside the cell. And what does a steroid hormone do? It stimulates protein synthesis. And what it synthesizes is two things. So the first thing it synthesizes is a channel or channels on the luminal side of the cell for sodium. Okay, so it's making those, and what's happening is it's allowing sodium to enter the cell, and let's enter the cell quickly. So now we've got sodium in the cell, and of course we don't want the sodium to stay in the cell of the collecting duct or the DCT. We want it in the blood. So of course we have our handy dandy sodium potassium pump here. And so the sodium is going to be pumped out of the cell and then into the blood. Well, of course, we have we have potassium out here and in the blood coming out, and it is going into the cell because it's being pumped in here into the principal cell. All right, so along with, okay, so we have to get rid of the potassium as well. So basically, as we're increasing potassium amounts in the cell, this hormone, aldosterone, is also synthesizing channels for potassium. So the potassium is going to go into the filtrate. So basically, with aldosterone, so the presence of aldosterone causes the secretion or excretion, really, of potassium. Because now we're going to get potassium it's in the filtrate. Now it's going to get into the urine and be peed out. So we're getting rid of potassium in order to maintain or to increase sodium. Okay? So again, sodium increases, potassium decreases the amount in the body. Okay. All right. Aldosterone usually when aldosterone is active, it's usually working with ADH. So increased aldosterone, say, works with ADH. So ADH is active as well. So the kidney has a huge effect on blood pressure because now you've got sodium going into the blood. Water's going to follow it, of course. So it's going to increase blood volume and increase blood pressure. Okay, I think that's about it on that. So just understand that now that we've talked about the entire nephron, that remember, filtration occurs at the renal corpuscle, just filtration. Everything gets filtered out into the filtrate. That will enter the proximal convoluted tubule, where 70% of reabsorption of all that stuff occurs. Then we go into the loop of Henle, the descending loop, only permeable to water. Water will come out of the filtrate, and as it goes down that medullary gradient, the filtrate will become more and more and more concentrated as water is leaving. The water leaves, goes into the interstitial space, and is also sopped up by the blood vessels, the peritubular capillaries around it. As it makes the hairpin turn, the osmolarity is at its most, it's 1200, and it starts to come up. And at that point, we're pumping out solutes into the interstitial space, which are also going into the peritubular capillaries as well. So now the osmolarity is now going down because we're getting rid of solutes. And then by the time we get to the distal convoluted tubule, the filtrate is fairly dilute, about 100. Then it goes into the distal convoluted tubule, into the collecting duct, which are only affected by hormones, and that filtrate is then tweaked depending on what's going on with the body. And yeah, so blood pressure, you know, the kidneys have a powerful, probably the most powerful effect on blood pressure and maintaining blood volume and all of that. All right, let's see. So the last thing we need to talk about, we'll talk a little bit about pH. So let's talk about pH and a little bit about how micturition occurs.